The next vulnerability in the login mechanism of InsecureBank is the forgotten and hidden button for admin users. So we'll change the source code to display this button, rebuild, re-sign, and reinstall it to the device. All right, let's get started. So let's make sure, first of all, that the Android emulator and application server are running. What I'll do is I'll merge the two screens together so you can see the changes instantly. Cool. So now let's check to see if the Wi-Fi ADB is enabled and connect the emulator to Kali. All right, so it looks like we're ready. So first up, I want to show you the piece of code that has this vulnerability. So let's go to the bytecode viewer and search for login to find that method in the login activity. Okay, here it is in the onCreate method. So here, a check is performed to determine if a resource string called isAdmin set to no. So if it's true, then the setVisibility8 method is used to set the button invisible without taking any space for layout purposes. So we can alter this value just by patching the application and changing the value from no to yes. So let's open up terminal screen and change the directory where the APK file is. And we'll use something called APK_tool to decompile the APK. So we'll run the APK_tool D command and add the APK file. Okay, let's go to the decompiled APK folder. And the file that will change is in the values folder under the resources folder. Open the strings XML file with Nano Text Editor. Scroll down. Yes, it's here. We'll just switch no to yes, and that'll make it visible. That's the hidden button, remember? So we'll save the file and exit. Now go back to the main directory. And now we need to rebuild the APK. So run the APK_tool B command. And now it's built. So the mobile app will not allow you to install the rebuilt APK on your emulator or phone without signing it first. So to achieve this, we'll need to create a key store. Give these parameters to generate a key, and a password must be specified when creating the key store, which will be needed later. And here we can skip these steps. Now in this step, write yes. Okay, so see how that generates a RSA key pair. And now it's in the current directory. So let's sign the APK with this key using jar signer. The SHA1 that we used to sign the APK file is not secure, of course, but we've especially set it so that we can exploit it. So add the key store and the rebuilt APK file and place it under the dist folder after rebuilding. Now we can finally add the alias and enter. Now enter the password that we used when creating my key store earlier. All right, re-signing is complete. So let's verify that the APK has been signed using jar signer. So run jar signer-verify-verbose-certs and add the rebuilt APK file. Okay, so it's now verified. So finally, the APK is aligned for optimal loading using a tool called zip-align. So we'll install it quickly with the sudo apt install zip-align command. All right, so I already have it. And to align the APK file, just run zip-align with the -v parameter. Add 4 numbers. So the 4 numbers define the byte alignment boundaries. Now it's always got to be 4 because that provides 32-bit alignment, or else it basically does nothing. So then you can add the existing APK file. Give a full path and a name for the new APK file. Okay, so the APK is now aligned and ready to install onto the device. Now, before installing the new APK, we need to uninstall the old one from the device. So we'll go to the app. So just click and hold on the app info and uninstall it. All right. Now we can install the new APK to the device with ADB. So first, let's check the device. We'll go to the directory. And this is where you created the new APK. Run ADB install and new APK file. As you can see in the screen, there is a warning because we installed the older version of the app. After Android 6.0 Marshmallow, Google Play Protect started warning users when they try to install apps targeting older Android versions. But for you and for me right now, we'll continue and disregard it because we want to test this APK file. All right, so as you can see, we have a success message and the new APK file is now installed. So Google Play Protect also asks us to scan the app. So we'll assume that the user didn't send an app for scanning. Let's open the InsecureBank application. And like I said before, the version of Android 10 will ask us to access these files. Prior to Android 6, you could reasonably assume that if your app is running, it will grab all of the permissions that it will declare in the app manifest. And for security testing, we will assume that the user has granted full access permissions for these files. And what are you looking at? We made the hidden button visible. So when you click on the button, you'll see that no function has been defined for this button yet, and it doesn't actually allow us to create a user, but it could also have been defined and you could pose a great risk. You get it. But the important thing here in this test is that we can statically change the function of the application.